says what we're going to be doing here is going over how to construct what is called a stem and leaf plot. A stem and leaf plot is another way of showing the distribution or shape of the data. So it's fantastic when we have numerical data and we want to see how that data is arranged. So without further ado, I'm going to talk about what makes a stem and a leaf plot and how to construct one. It's really cool. So let's check it out. You're given a problem that says the following data shows the number of students in each classroom in a hallway. Make a stem and leaf plot. So what we have right here is a list of numbers of students. 15 is in one classroom, we have 26 students in another classroom, 20 in another, and so on and so forth. What I like to do is reorganize the data, much like you would do when you're finding the median of the data, or sometimes even finding the mode. I find that to be very helpful. So I've reorganized the data here and made sure that I have every single one of the numbers that I had in the original list. From there, we need to construct a stem and leaf plot. To do that, like so many of the tables and graphs that we make sure that we have a title, and here's the title, Classroom Population. I thought that was rather fitting to the problem, nothing creative. And you always need to have a key with a stem and leaf plot, and here is the key. You have the stem. The stem is usually, if not always, going to be the first of, well, I guess all of the digits of each number, except for the last one, which will be the leaf. So for instance, the 15 that we have in our data set, since all of the data in here are 2-digit numbers, the stem is going to be the tens place, and the leaf is going to be the ones place. So 1 with a line followed by a 5 means that there are 15 students in that classroom. That's the stem and that's the leaf. So what we do is we take stock of all of the types of numbers we have. They're all 2-digit numbers. They start in the tens, right, with a 1 in the tens place, go to the 20s, 30s, and then eventually to 40s. So all of my stems should be 1, 2, 3, and 4. Again, being all of the leftmost numbers in each number, except for the final digit. So we have 1 and then 5. 1, and then I would put down a 5. And that's all I'm going to write. So that shows that there's one classroom with 15 students. Then we have a classroom with 18 students, so I put down an 8 here. We then have two classrooms with 19 students. So I'm not just going to put down one 9 because there's two classrooms with 19. So I'm going to put down two 9s, and that represents that there are two classrooms, each with 19 students. And that's it for the numbers from the teens. So now we're going to go to the 20s. There's one class with 20, so I'm going to put a 0 right there. One class with 22, there goes a 2. 1, 2, 3 classes with 26, so we put 3 6s. It shows the frequency, then the number of classes with 26 students is 3. And then we have 27, so I'm going to put down a 7 for my next leaf. Stem, and these are all the leaves. So this represents 20, 22, 26, 26, 26, and 27. Finally, we have a 29. A lot of classrooms with students in the 20s. Then we go to the 30s, and we have one leaf, which is 0, 3 then 0, and finally 31, so 3 followed by a 1. The only number remaining is 45, so 4 followed by a 5. So let's talk about what all of this means. Well, we can see from the stem and leaf plot, just by a quick glance, that most of the classes have around, well, somewhere in the 20s. Right? And that's just by a quick glance. We could ask other questions like, what is the mode of the data, the most occurring number? Well, the most popular population of classroom is 26, and there's 1, 2, 3 classrooms with 26. If I asked how many classes have between 10 and, well, 29, including 29 students, you could quickly look at this and say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 classrooms with between 10 and 29, including 29 students. So you could ask a lot of questions like that. You could ask, what's the range of the data? Right? The range would be the highest number, which is 45, minus the lowest number, which is 15. So in this hallway, there's 45 minus 15, or a range of 30 students. So we can ask so many questions and get answers to those questions from these stem and leaf plots, which show a really great distribution of the data. Very cool stuff. In this very quick problem, I'm going to continue on with my explanation of stem and leaf plots and show you how do we construct a stem and leaf plot when we have numbers that have more than just 2 digits. What we do is, we still need to construct a key like normal, and here I don't have really any kind of category for the data because I just want to focus on the numbers, but our key tells us that 145 can be written as 1-4 followed by the leaf, which is a 5. So your stem is almost always, if not always, going to be your first however many digits all the way up to the last digit in each number. So our stem should be 1-4, 1-5, and 1-6. That'll cover all the types of numbers we have in this list of numbers. So I put down a 1-4, followed by a 1-5, followed by a 1-6. Now that we have those stems, we just now need to put down the leaves. So the lowest 140 number is going to be 5, so that's 145. Just like the key says, 14 with a line between it and the 5 means 145. Then we've got 147 and 148. So let's check those off. We're going to have 7 followed by the 8. Then we've got our 150s. We're going to have a 0 followed by a 3 for 150 and 153. So those are our leaves there. Finally, we've got our 160s. So that's going to be a 0 followed by a 2 to represent our numbers. So just a really quick little extra piece that shows you how we write a stem and leaf plot for when we have more than 2 digits.